Okay, let's talk about negative and zero exponents. Zero exponents first. So the first thing to remember is that anything to the zero power becomes the number 1. Now I do think about that as any base raised to the zero power. So for instance, if I have x to the 0, that is 1. If I have 5 to the 0, that is equal to 1. If I have 3x to the 0, since 3x is the base, any base raised to the 0 power becomes the number 1. Even if I have something like 2/3 to the 0 power, that becomes the number 1. The only time this is different is when you look at something like 7x to the 0 power. Because now, unlike the previous examples, the base is just x. 7 is now the coefficient. So this is really equal to 7 times x to the 0 power. Think about what we have before. X to the 0 power is really just 1. So we have 7 times 1, which is 7. Same thing if I had about 2y to the 0. Recognizing that y is the base, 2 is the coefficient, this is equal to 2 times y to the 0, which is equal to 2 times 1, or just 2. It works out the same way if it is embedded within larger problems. So if you were given something like 30a to the 4th divided by 10a to the 4th. Knowing that the 30 and the 10 are both coefficients, we're really looking at 30 divided by 10 times a to the 4th divided by a to the 4th. 30 divided by 10 is 3. A to the 4th divided by a to the 4th is a to the 0. 3 is a coefficient. A to the 0 becomes the number 1, so this is equal to 3 times 1, or just 3. Even if it was further embedded in, so if I had something like 27, c to the 9th, d to the 8th, divided by 3c to the 9th, d, I would split that up into 3 separate fractions. I have bases of c and d. I have coefficients of 27 and 3. So this would be 27 divided by 3 times c to the 9th over c to the 9th times d to the 8th over d, or technically d to the 1st. 27 divided by 3 is 9. C to the 9th divided by c to the 9th is c to the 0. D to the 8th divided by d is d to the 7th. I look in there, c to the 0 really is 1. This is really 9 times 1 times d to the 7th, or just 9d to the 7th. That's zero exponents. The next and more difficult concept is usually negative exponents. Negative exponents create fractions. That is huge. Negative exponents do not create negative numbers. Negative exponents create fractions. Those fractions are really reciprocals of the positive versions. What do I mean by that? Well, if I give you something like 2 to the 4th power, 2 to the 4th power is 2 times 2 times 2 times 2, which is 2, 4, 8, 16. Well, 2 to the negative 4th power is going to be the reciprocal of that. Reciprocal means flip the fraction. So if I think of this as being 16 over 1, 2 to the 4th power is 1 over 16. You could even think of it as the reciprocal of the positive exponential form. So 2 to the 4th power, if I consider that being over 1, 2 to the negative 4th power again is over 1. If I flip that fraction and make the positive exponent, it would be 1 over 2 to the positive 4th. Okay? And that's really all there is to it. Now, of course, there is reasons why that is. If I think about 2 to the 4th power being the answer to a division question, so for instance, if I did something like 2 to the 1st divided by 2 to the 5th, the quotient rule tells me to keep the base and subtract the exponents. So this would give me 2 to the negative 4th power. But what if I thought about this in expanded form? 2 to the 1st means 2. 2 to the 5th means 2 times 2 times 2 times 2 times 2. If I use examples like I did before, and I divide out these pairs of 2's, that means the top is just left with the number 1, and the bottom I see 4 copies of 2. So I could write that as 1 over 2 to the positive 4th. That kind of thing will always work if you think about where the exponent actually came from. It works the same way with variables as it does with numbers. So if I want to know what x to the negative 5th is, I think about that as being x to the negative 5th over 1. I remember that negative exponents are reciprocals of the positive versions, so this would be 1 over x to the positive 5. And that's it. Now, of course, like I did before, there's reasons why that is. So think about where x to the 5th could come from. Maybe it's x to the 2nd divided by x to the 7th. 2 minus 7 is equal to 5, or negative 5, so this could be x to the negative 5th. And you could really make this any question that you wanted to, where the answer is x to the negative 5th. Again, if I chose to do this in expanded form, x squared means x times x. X to the 7th means x times x times x times x times x times x times x. Divide out the pairs, and I'm left with 1 over x to the 5th power. So this is equal to 1 over x to the 5th power. This becomes a little bit more complicated when you involve coefficients. So if I have something like 2y to the negative 3rd, keep in mind that 2 is a coefficient. The negative exponent is actually attached to the y, not the 2. So keep in mind that this is 2 times y to the negative 3rd. Based on the examples that we've done, y to the negative 3rd becomes 1 over y to the positive 3rd. The 2 stays just like it was, except since this is a fraction, I'm going to make the 2 a fraction as well. So I'm going to make this 2 over 1. And now to simplify it, I just multiply across. So I have 2 over y to the 3rd power as my final answer. Okay? That is the basic idea of positive and negative exponents related to each other, and of course anything to the 0 power. Don't forget, anything to the 0 power equals 1. Negative exponents create fractions. Have a nice day. I hope this helps.